Right, so now we're going to be talking about what happens in the shadows when we use JavaScript. So we're going to be talking about threads, call stack, and event loop. So what is a thread? Think of it as a timeline where your program executes things. So JavaScript is single threaded. So this means that you can run one piece of code at a time. We discussed this. So in the left side of the screen, we have just one file, right? Our application just contains one file. It's going to run a function, then a console log, function 2, console log 2, a third function, and then a console log. Really, really simple. So when the application reads this app.js, our program is going to start. So the system will open a new thread. You need to think about this thread as a single line or a timeline, just like a timeline where things are going to be happening. So the program is going to start, it's going to read the file, and it's going to go and execute the first function. Then it's going to go to the console log, then function 2, then console log 2, function 3, and then of course the console log 4, and our program is going to exit, it's going to be done with this. So JavaScript is single-threaded, one timeline, just one timeline, executes everything, one thing at a time. Other programs like Groovy, for example, can run multi-threads, just like this. They can run and they can process several things at the same time, not JavaScript. Other programs just like Groovy, for example. So, this is cool. You might be thinking it's better, but well, it depends on what you're doing. Multi-thread uses more processing power and uses more resources. So computers as we advance have more cores to be able to realize multitasking operations. So more cores, more processing powers, but that is a different topic. Again, JavaScript, it's single-threaded, single timeline, one thing at a time. And you must be thinking, dude, with non-blocking, we were executing things at the same time. Where when we do an async code, something is happening, it's going somewhere and just processing everything at the same time. Well, not really. So this is how the browser works. Looks like we are doing things at the same time. We are running something in parallel, but we are not doing this. The system will not do that. So in the next on the next chart, I'm going to explain you how Node.js and how actually this works. Right, to explain this, I will have to begin with the call stack. Maybe you already know what the call stack is. If you do, you can move forward. If not, stay. So we know now that JavaScript is a single-threaded language, and it can do one single thing at a time. So the call stack is going to handle our single thread. So our call stack is the thread. So where everything is going to be executed. It's just like a list. Try to visualize it like that. Just a list. So in the left side, we have our application. We have three different functions: function number, function name, and function symbol. And after the system is going to read that function, is going to execute it. Right here, after each function, we have the number, name, and symbol. All right. So the application is going to start. And first, we're going to be executing the application. Just run our application. Then it's going to go to the first function. It's going to see that we are executing, of course, and we do the console log, and then the system will exit, right? It's going to go back to the app instance. Then we have the function name. So it's going to execute and console log Francis, and then it's going to exit name. And then we have the same thing with symbol. It's going to go output the whatever symbol it's outputting. In this case, just a dollar or currency sign. And then the application is going to exit. And then the app is going to be done. So everything exits. So everything was made in a single line, single thread, everything one after the other one. Really simple. Let's see a different example. Okay, so now we have a much more complex example with a little bit more logic. So what is happening here? First, we have three functions, and we are not just triggering the functions after the program reads the function. At the end, we are calling print result, and we are passing an argument of 10. Now, print result contains a variable with a get result. It's just calling to a different function, a function outside print result. Now, get result is going to grab the number that we passed as an argument, and it's going to call a different function called getRandom. Now, getRandom is going to be returning just a random number. Then inside getResult is going to go back to getResult. We're going to multiply the argument by the getRandom number. right? And then it's going to go back at the end to print result. It's going to go back to the beginning, and we are going to be doing the console log for the result, right? Okay. So again, we have a different example. On the other one, we are just executing everything one after the other one. But in this one, we have functions inside functions, just the nested functions. So the application is going to run, right? It's going to go to the call stack, and then we're going to run the print result with the argument. Good. So this function is going to call to get result, but print result and the argument is going to stay there because it's not done. But get result is going to be calling a different function, which is going to be get random. Now, get random is the last piece of the chain. So when it's done, it's going to return back to get result. Get result is going to go back to print result, and then print result is the first one. So it's going to do the console log for the number, and it's going to exit. And then the application is done, and our call stack, our timeline, it's done. So this is what's happening on this. After we execute each function, if it's not done, it's going to put the next line of code on top of the previous one if it's not done, right? So it's not just executing and exiting that function. It's stay there on the call stack until everything is done. But everything is in a single line, you know? That's why it's called call stack. It's a stack of things. Okay, that's good. Let's see a different example. Okay, so we have a different example. We have a function called message that whenever we trigger this function, we run this function, the function calls the same function. So we have an infinite loop. All right, let's see what happens. The application is going to start, then it's going to call message, it's going to call message, it's going to call message again and again by 10, by 50, by 100, and so on. So I know that when you were learning JavaScript and learning about loops, I'm pretty sure that you got an error message. So you're going to get maximum call stack size exceeded. So now that you know what the call stack is, you can know why you're getting this message. Of course, you have a maximum amount of calls you can put inside the call stack. Now, since the call stack is never going to end because you have an infinite loop, of course, the system is going to crash and it's going to stop the call stack. So, okay, again, we know a lot of things now. We know what blocking, non-blocking, and what the call stack is, and that JavaScript is single-threaded. There's one more thing I didn't show you. What happens if we have asynchronous code? Right now, we have just functions, plain functions. We run one after the other one. But what happens if you have a set timeout of 5 seconds? Because, you know, the system is going to recognize the set timeout, it's going to send it to a special place, but it's going to keep running the next function. It's going to go to the next line of code. So let's see an example with a set timeout. Okay, so same idea with the app.js. We have a function that gets triggered right away. Okay, the system is going to read it and it's going to execute the message function. Then we have a set timeout, right? And it's we're going to be running a console log after 5 seconds. Really simple. So this is what's going to happen on the stack. So the application is going to start. The first function runs. We get the console log and it's going to exit. All right. Then the timeout is going to be running. So with the callback, with the set timeout, we have a function which is the callback, and then the timeout, the time. So the system is going to read this, is going to grab the callback and the timeout, and it's going to send it to a magical place, right? So of course, since this is non-blocking, we're going to get the console log before we see the console log deferred of the set timeout, right? Okay. The console log is going to exit. The application is going to be done. And then after 5 seconds, we're going to get console log deferred, and then it's going to exit. And then the application is done. So where in the hell is the callback function of the timeout going? So who decides when to show it and how to show it? So right here, we have to talk about the APIs. And this call stack is going to be working with something that called callback queue and the event loop. So it works with other things. This is the dark place, the magical place. Right, so JavaScript can only run one code at a time. That is the law. But we are running something in parallel here with asynchronous code, like the set timeout. So how can this happen? Well, the browser have APIs. In case of the browser, in this case, well, it's going to be B8 in case of Chrome. So we talk about this. And in case of Node, it's going to be C++ emulating V8. So with Node, we get kind of the same flow. So this API is going to be listening for things to do. In this case, it's going to be the set timeout and other async actions, of course. So just like Ajax, for example. So after they go through the API and get resolved, they will go to the task queue at the bottom. And there's inside the task queue, there's something watching this queue called the event loop. Don't worry, I know it looks confusing, but we're going to be running the chart right now. So again, we have a function called message with the console log. Then we have a set timeout with 5 seconds, and then, just the console log for a message, right? Okay. So the application is going to start. Good. Then we're going to go to the first function, which is message, and we're going to console log the message. Good. Then that message is going to be done. The function, it's done. Good. Then we go to the set timeout, and we have a callback and a timeout. Okay. So the system is going to grab that because the API knows that this is a set timeout and it needs to be sent to the APIs. So it's going to go to the APIs. And we're going to be running that callback in 5 seconds. Meanwhile, it's going to go to the console log, and we're going to console log message. Good. And then the console log will exit, and the app is going to exit. Now, after 5 seconds, the APIs is going to send the callback to the task queue. Now, inside the task queue, you're going to have the event loop. You can have something called event loop. Now, the job of the event loop is to look at the call stack and look at the task queue. And it's going to say, okay, is the call stack clean, ready to be used? Well, no. Okay, so I'm not going to do anything. I'm going to wait. And then it's going to be asking again to the call stack. Is it empty? Well, yes. Okay, so when it's empty, it's going to grab that callback we have on the task queue. It's going to push it to the call stack. And then we're going to see this console log deferred, and the application is going to be really done. So this is a very simplistic look of the whole process that this is doing. And Node, of course, uses the same logic because we are using JavaScript. Of course, there's, again, more things to it. So let's see a different example, because on this one, we just have a set timeout. We just have one async function. What happens if we have more? Okay, so now we have a much more complex example. We just get more, we have more timeouts. Very simple. So now the thing is that the timeout contains a 0 amount of seconds. We are kind of trying to trick the APIs. So okay, let's see how this works. The application is going to run, and then we go to the first function, which is the message. It's going to console log the message, and then it's going to be done with this. Then it's going to go to the set timeout, and it's going to send it to the APIs. Now, again, 0 seconds. So this API is going to send it back to the task queue because it's done. It's ready to be executed by the system. Now, again, since the event loop, the job of the event loop, it's asking the call stack if it's free to be used. Since it's not free because we have the app and more things to run, the event loop, it will not send the callback to the call stack. Okay, so we're going to go to the second set timeout. It's going to go to the APIs and then to the task queue. We're going to have the third set timeout. It's going to go to the APIs and then the task queue. And at the event loop, it's always asking the call stack if it's free to be used. Okay, since we are not done on the call stack, we're going to do the console log message. And then, of course, it's going to be done with this. It's going to be done with the app, reading whatever code we have inside the app. And then the event loop is going to be asking the call stack, okay, are you done? Yeah, okay. So it's going to be pushing this callback. So then it's going to be done with this callback. It's going to push the second. It's going to be done with the second. And it's going to push the third. And it's going to be done with the third. And our application is done. So this is how things happens with async code. We are not really running things in parallel. Everything goes in a straight line inside the call stack, one thing after the other one. But there are things in the background, just checking the call stack to see if they can push actions into it. But it's only one single timeline, right? Okay. So now we know how JavaScript works with Node and the browser and everything else. But how can Node work with JavaScript? All right, so in the next section, we're going to be talking about this.